In an experiment, we fire a gun vertically upward, and when the ball reaches the maximum height, it is 2.25 meters above the floor. When the ball left the gun, it was 0.35 meters above the floor. Now we're gonna ignore air resistance, and they want us to find the speed or the velocity of the ball at the moment when it leaves the gun. Okay, we're gonna have our x and y axis, and our x-axis, our y-axis gonna be right here where the ball goes up, and our x-axis is gonna be right where the ball leaves the gun. So this will be right here. This will be our x-axis, and this will be our y-axis. Okay, so x0 will be at this point, y0 also at this point, and they are asking us v at y0. How much is that? So let's find out some things. We know gravity, that was negative 9.8 meters per second square. We can find out our y, our final y. Y0 is down here, and our y, our final y, is up here. Our final y, we are interested in this difference, which will be 2.25 minus 0.35 meters. So 2.25 meters minus 0.35 meters, and that's gonna give us our y, which is 1.90 meters. Okay, we have another very important piece of the puzzle. Now to find our velocity that they are asking, we're gonna use our kinematic equations, and we're gonna use the one that I have marked as number 3 on this little card. So we're gonna use this one. I'm gonna put this up here so we can see. So v, this is the general form, so I'm gonna rewrite it since we are working only in the y axis. So I'm gonna rewrite it as vy equals v, and this will be the y0, our beginning v, on the square, plus 2, our acceleration is gravity, so we're gonna plug in just g, and delta y, or delta, here the difference in x, but we are working in the y, so we can just put y minus y0. And this delta y for us will be the y that we found here. We can also put delta y in the difference in the y. Okay, let's start plugging in. Our v at the top, we also know that one. We can write it down. V at the top will be a 0. This point is when the ball reaches maximum height, stops for a brief moment, and starts coming back down. That's our location, and the velocity at that point is 0. So this one will be 0. So 0 equals v at y0 on the square plus 2 times our g is negative 9.80 meters per second square times delta y, and this will be our delta y, the amount of distance that it moved up from y0 to y. Maybe I should denote this as delta y from the beginning, just so we don't get confused. So, times 1.90 meters. Now we're gonna solve for this. We're gonna bring it to the other side, equals this whole thing, 2 times negative 9.80 meters per second squared times 1.90 meters. We're gonna take the square root of both sides, and that's gonna give us, well, we have the negative, both negatives here. There you go. We brought this to the other side. Let's not lose the negative. There's another negative here. Both negatives cancel each other, so we're gonna have nice two positive values on both sides. Now we're gonna take, this time we're gonna take the square root of both sides, and this will give us the velocity at y0 is 6.10 meters per second. We can also write here that we took the square root of both sides. And this would be our final answer.